Hello. So I'm making this video just to help you on lab number 4. As you see here, um, this lab is about uh, digital multimeter, internal resistance, and LT spice. Okay. So as you see here, you should learn in the learning objectives of this lab include number one, the concept of internal resistance. Okay, so what we are gonna do now, or as I explained in the lecture, any voltmeter or any ammeter has an internal resistance. Okay, ideally, any voltmeter should have infinity internal resistance. Okay, any ammeter should have zero internal resistance. And as I told you in the lecture, the problem with these resistors, they are gonna make errors in the measurement if 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 in case of a voltmeter, if the um if in case of voltmeter, the internal resistance of a voltmeter should be much higher than the resistance of the circuits. In case of ammeter, it has to be much smaller. Uh, so what we are gonna do here, you need better to understand the concept of internal resistance. You will also measure it. Okay. It's a very important concept because this can cause our error in measurements. Okay. The second part you need to learn in this lab is actually how can you make a current source. What we did in the previous labs, it was we have a power supply. This power supply has 4 channels. These channels can be used as a voltage source or current source. So this is the first time we use a current source. We used voltage sources before. So in the future now, you should be ready to use voltage sources or current sources. Okay. The last thing here we will do here in this lab, you are gonna download and you are gonna use a simulator for circuit simulator, very famous one. It is called LT Spice. Okay, so let's start one by one. So let me tell you here before we start. As you know, or that's what you have done. That's what I explained in lectures. If you have a voltmeter and you want to measure the voltage between this point and this point, so you have to connect this voltmeter parallel, as you see here, between this point and this point. Ideally, this voltmeter should not have internal resistance because this internal resistance is going to be added to the circuit. That means it's going to make disruption. That means the current coming here is not going to be the same current after you connect the voltmeter. You see what I'm saying? It's like you change the circuit, you added resistors, okay? However, as I told you, if the internal resistance is much bigger than R2, the error will be very small, okay? Same thing here, as you know, ammeter has to be connected in series. So if I want to measure the current in this branch, I have to connect the ammeter in series this way. So I have to open the circuit. The current I want to measure has to flow. It has to flow through the ammeter this way. Okay. Same thing. Ideally, this ammeter should have zero internal resistance. So it's like a short circuit. However, practical ammeter have some resistors here. So it is like I have added by putting the ammeter here. Actually, I added one resistor to the circuit. So the current here is not gonna be the same current for the circuit if I don't have an ammeter. Okay. So, but again, this can make a small error or it can make a big error. Okay. How? If the resistance here comparing to the other resistors you have here, if this resistor is much smaller than them, so actually it will be a very small error, acceptable error, because most of the voltage will be here. This part will take a very little voltage, which should be okay. Okay, it's not ideally, but the error will be very small. However, if this resistor here is comparable to these two resistors, yeah, now we will see this one is going to take a big voltage drop. So now the measurement is not going to be accurate. So again, let me summarize what I said, because what I said, any voltmeter, if you want to measure between two points, you have to connect it in parallel. This is if you want to use a voltmeter to measure a voltage. If I wanna use a meter to measure current, I have to connect it in series. So I have to open. So you see the meter here series with this resistor, series with this resistor. Okay. However, what I'm gonna do right now, because I wanna measure the internal resistance of the voltmeter, okay, I'm gonna connect it series, not parallel, just to measure the internal resistance. But if you wanna, don't be confused. If you wanna use the voltmeter, it has to be parallel. Most of the time we will use it, but in this experiment, as you will see right now, it's gonna be series because I wanna measure the internal here. So I'm gonna switch in this, but normally what you are gonna do in all labs, the ammeter has to be series, okay, if you want to use it for measurement. But what we are going to do in this lab, as you will see, I'm going to connect it in parallel. That's because I want to measure the internal resistance, okay. So just in this lab, so let me come here, what I'm explaining here. So what I'm telling you here, again, that's what I told you before. Any ideal voltmeter should not have any resistor, but actually same thing here. That's what I told you. However, because they're not ideal, so they have some internal resistance. So this is, yeah, so that is why any voltmeter should be, it has to be modeled, it has to be modeled this way. It's an ideal voltmeter and internal resistance. For sure, we wish, or we want this internal resistance to be too high. Infinity for sure is the best case, but that's not practical anyway. Same thing here for the ammeter. It's actually, we can model any ammeter like a series resistant and ideal ammeter, okay? Uh, if this is, everything here is a practical ammeter. So that means, for sure, we wish if this resistance can be zero, short circuit, okay? So as I told you now, what we are gonna do, I wanna measure the value of this resistor here and here. I want to measure this value. So what we are gonna do, you have to use this circuit to measure the internal resistance of a voltmeter, and you have to use this circuit to measure the internal resistance of an ammeter. Okay. So let's see here. So what we are gonna do here, guys, as you see, we have a resistance R1, right? And then I'm gonna connect the voltmeter series. So this is a voltmeter here. We call it DUT. DUT means device under test. Okay. So I'm gonna connect here the voltmeter series to R1. Again, guys, please don't be confused. Always, if you wanna measure voltage, you have to connect the voltmeter parallel. Okay. But here only in this lab, maybe this is the only lab you are gonna connect the voltmeter series, simply because I wanna create a voltage divider between R1 and R internal. So as you see here, guys, I need one more. This is the main idea. I need one more voltmeter here, as you see, to give me. So I need to use two voltmeters. This one, actually, I wanna measure the internal resistance of this one, but I need another one here to give me the voltage VT. Okay. Now what I did on this the measurement here is going to be the voltage across the internal resistance. So now what I did, guys, I did a series resistance between R1 and R internal. Okay. So that now if you know VT, right, and you know the voltage across this resistance, you can use the formula for voltage divider to calculate R internal. Can you say it again? I will say it again. Look here, guys. You have two resistor in series, R1 and R internal, okay? I know R1, I don't know R internal. I know the voltage here across both of them. This voltage is going to be divided between R1 and R internal. I know the voltage across R internal. So if you just apply the formula of voltage divider between, this voltage is going to be divided between R1 and R internal. If you apply the formula, you have everything except R internal. That's how you can calculate R internal. Okay. For the second one here, guys, what I want to measure the internal resistance of an ammeter. So as you see here, I'm gonna connect the ammeter here parallel. Again, please don't be confused. Always we connect any ammeter series to measure the current. The current you want to measure, it has to go through the ammeter. So that's why it has to be series. However, only in this lab, I'm gonna connect it parallel. That's because I'm not doing measurement. I'm not measuring the current here. I'm doing it this way just to be able to measure the internal resistance. So what I did here, guys, as you see here, we are going to use a current source, and as I told you, this is the first lab. You are going to see how can you set up the device or the power supply you have to make it a current source. Okay. So the reason this is the ammeter is here. Okay, you need to connect it parallel to R1. For sure, I will give you the value of R1 here and R1 here, and then all what you have to do, you need another ammeter to measure current here, which is I total. Okay, and then this ammeter is gonna measure the current here. See what I did here, guys? What I did, I actually here you can see R1 is parallel to R internal. Okay, and and I created current divider. Okay, so here in current divider, if you know the total current and you can calculate the current on each branch here. Okay, you have the formula for that. But if you see here, I should measure this current using this ammeter. I should measure this current here, okay, using this ammeter. Okay, I know R1, I don't know R internal. So now you can apply the formula for current divider. You have everything in the formula except R internal. By this way, you can calculate R internal. Okay, so that's what I'm saying here. So let's go to yeah, so maybe it's important to know that this effect is most significant in high resistance circuit. Okay, that's what I told you. When I use a voltmeter to measure a voltage, okay, this R internal must be much higher than the resistors of the circuit, or the resistor I'm measuring the voltage across it. Okay. Uh, However, this is to get accurate results. However, if this is not the case, you are not going to get accurate results. So this is something very important to understand. So that's why this concept is important, because this is a part of your understanding how can you use measurement meters. Okay. So second one here, again, same thing for the current, for the ammeter, but here in the ammeter, because you connect it in a series, this internal resistor has to this internal whatever, we cannot make it zero. That's a fact. We wish if it is zero, but we cannot make it zero. Okay. So if the other resistors in the circuit are much bigger than the internal resistance, okay, the measurement will be accurate, because it's gonna when you add a meter to the circuit, is gonna cause a very little disruption. Should be okay. Okay, so let me go to here. Yeah, some details are here. The first part here in the experiment, guys. Number one, you have two different meters. Okay, you already from the previous labs you learned how to use them. So what here I want to measure the internal resistance of this meter key site. Is that okay? So key site here, this is the one that you have to put it here in the voltmeter, and this is the one you have to put it here. Okay, the other meter used in the previous lab, so should be here. Okay, so what we are gonna do here, what I told you to do here, construct the circuit shown in figure in figure 2. Select a resistance value between 4 and 10 mega ohm. This is for R1. So R1 here, that's what I told you here for this circuit. R1 here has to be, it's any value, it's up to you, but it has to be between 4 mega to 10 mega. Okay. You can see here I selected a big value. You know why it's a big value? Simply because I know this one also will be a big value. You see what I'm saying? So if this is a big value and this is a big value, okay, I will see a noticeable voltage here. But if I use if I use a small value here, very small value, okay, so what's gonna happen? This voltage is gonna be very, very small. Result is not gonna be accurate. I want to measure this resistance in an accurate way. So when I select this resistance, I will try select a big one that's comparable to this one, so that you can see a noticeable voltage here. You can reduce the error. That's what we did here. Okay. And then here I told you the power supply, make it 8 plus or minus 1 voltage. That means it's between 7 and 9 voltages. Okay. Here, here I give you everything here, details. And then all what you have to do here, guys, you have to measure after you set the circuit this way. You have to measure the voltage here. You have to measure also this voltage. Okay, you need to know R1. You already know I1. So now the only thing you don't know is R internal. So you have to fill up. You have a table here in. Yeah, so you have to fill up this table here. Okay, you have what is R1, what is a DUT voltage. Okay, and by this way you can calculate R internal. You need to calculate R internal. Okay. Yeah, here I'm just telling you why R1 is this. It has to be too large, too big value for R1. Okay, can this contribute to the accuracy? That's for sure yes, because the other resistor I'm measuring, I'm expecting it to be big value. Okay, so just to if I make this one too small, okay, so you will find maybe there may be a error, okay, in the measurement, but I want to make it comparable so that I can see a noticeable amount of voltage across both of them. Okay, we're going to repeat the same thing for internal resistance ammeter, but this time, as you see here, you are going to use this circuit. Okay, so you need here, you need to calculate R1, and you can guess that R1 here. Okay, um, um, so I just hopefully you are not confused from what I said, guys. What I want to say here, in order to get accurate measure results here, I have to make sure this R1 close enough to R internal in the same range. You see what I'm saying? Because if some one of them is much bigger than the other one, you may find all the voltage here. Okay, if this one is much bigger, that's same thing here. So here, what we're gonna do, as you see right now, when I select R1, I have to make sure that R1 is a small value. Okay, why? Because I'm expecting R internal to be a small value. That's why here, if I told you here, when you select R1, select something between 20 ohms to 50 ohms. Okay, and now you have to use the current source to make a current that is 65 milliampere plus or minus 5. That means any value in the range of 60 and 70 milliampere should be okay, right? And then once you do that, all what I need is I need to know what is this current here using this ammeter. I need to know what is the current here, okay? And I already know R1, okay? After that, you can use the current divider formula. You have everything in the formula except R internal. That's how you can calculate R internal. I give you, because this is the first time you use a current source. So here I give you some guidance. How can you set up the power supply to measure, to act as a current source. Okay, guys. Again, what's really important is now I don't want you to forget what we have done before, right? So what we have done before, we used the power supply as a voltage source. In this lab, you are learning how can you use it as a current source. Okay, you learned it before as a voltage source. Okay, now you are learning current source. Okay, in the coming labs, you should not forget, because in the coming labs we are going to use it as a current source or as a voltage source. You still what you are learning in this lab, well, I'm going to use it in the coming labs. Okay. This is one part here in this lab. The second part in this lab is actually you need to download a simulator. Very important, very interesting simulator. We call it LT Spice. So here I give you in the pre-lab here, I give you this link. You have to go to this link. You have to download it. Here I give you a tutorial. How can you use the LT simulator, circuit simulator. Also here this YouTube video is very important. You can watch it. It will give you the basics. How can you use the Elite Spice? Okay, Elite Spice is a computer program simulator. You can draw the circuit, and then you can ask the simulator to calculate the voltage and the currents everywhere. Okay, very important. Okay, so again, what you are learning in this lab, I'm gonna use in the coming lab. So that's what I'm telling you here. So what I'm telling you here, guys, this is the first time you are using Elite Spice. However, in the coming labs, usually what I'm gonna do here, you have a circuit. I will ask you to solve the circuit by hand. Okay. and then I will ask you to get measurement from LT spice. So most of the coming lab you will use LT spice, okay? And then number three, you are gonna perform experiment, and then you need to compare between them. Okay. So again, number one, calculations. You calculate the currents and voltage by yourself. Number two, you can run the simulator LT spice and get some results for voltage and currents everywhere. Number three, measurement, and then compare between them. So usually what you are going to notice is that when you solve a circuit by hand or simulator should almost give you the same result, okay? Almost the same result. However, in the experiment, you will see there may be a very small difference between what you get in the experiment and what you get here by hand or by simulator. This is because, and every time I will ask you, compare and tell me why. Every lab I will tell you that, okay? This is simply because component tolerance, okay? So you assume a resistance 1 k ohm, as I told you before. So actually it may not be 1 k ohm. It may be plus or minus tolerance, okay? Also, because we ignore the impact of voltmeter and ammeter. So even if the resistor of the voltmeter much bigger than the circuit or the resistor of the ammeter much smaller than the resistor, still there is an error. Okay, but we are trying to minimize this error. So that's why we have measurement errors, and because all of this again. Because of this, your measurement may not be exactly same thing like what you expected. However, if it is close enough, we are okay. Okay, guys. So here in this course, or usually this is our mindset. Our mindset is we 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 may not get exact numbers. Okay, but if it is the error is very small, it should be okay. Okay. It's up to you to define what do you mean by very small. For example, 4%, 5% usually should be okay. So, but anyway, so here, what you have to do here, guys, is in the third part, as I told you, you need to download LT Spice, okay? And you need to read the tutorial how to use it. It's just very easy program, and also YouTube, okay? You can just click and build the circuit, and then you have everything here. So after that, what you have to do in the third part, you have to implement this circuit as you see here. So in this circuit, you have a voltage source, 20 volt. You have R1, R2, and R3. So you have all resistors. You have a voltage source here. Okay. So this one is similar to what we had in the class. So can you solve this one by hand to get V1 and V2 and get the current everywhere? You should be able to do that. Okay. So you need to solve this one, similar to what we did in the lecture, to find the currents and voltage everywhere. You have to do that in the pre-lab. And if I go to the pre-lab, that's what's written. So here in the pre-lab, for the circuit shown in figure 4, okay, you need to solve it you need to do calculation by your hand. I need to find V1, V2, and then you need to find I1, I2, I3, okay? Same thing here. You need to repeat everything again, but this time for the simulator. So this is the result you will get by calculation, and this is the result you need to get it from LT Spice. Okay, this is the pre-lab. You have to do it before coming to the lab. As I told you before, if you see the deliverable here, let me come. Yeah, this is what should be in your report. Okay, so the deliverable here is, as you see here. There are 18 points for the pre-lab. If you don't do the pre-lab before coming, you will get 0 in this part. Even if you upload it with the final report, because you didn't do it before lab, you will get 0 in this part, okay? One more thing, very important, guys, because all what you have only 1 hour and 50 minutes. You don't have much time. So try to find all resistors before you coming. You don't have time to waste the 10, 15 minutes just looking for the value of a resistor. You have to do it before you coming. Also, you need to connect the circuit before you coming, okay? Because for the third part here, guys, as I in the pre-lab, you will calculate the value of V1, V2, and R current here, current in R2, current in R3. You are gonna do the calculation. Also, you are gonna simulate it. So you are gonna get simulated results. Okay. Also, you need to implement this circuit, and then you need to measure V1, V2, and the currents as well. Okay. So, and then I will ask you, so now you have calculated, you have simulated result, calculated result, simulated result, measured results. Is that okay? So again, you should know how to connect a circuit like this one. It's very clear. R2 and R3 are parallel, so you have to make sure they are connected to the same node in the breadboard here and here. Okay, and this node should be the same node connected here, and then this R has to go to another node here. Okay, and all of this should be the same node as you see here in the breadboard. Okay, guys. That's it. So again, if you go to, and then I give you here some pictures how to do the connection. But again, unfortunately, I tried to help a student last time, but unfortunately, some students, so as you see here, you need 2 meters. As I told you, we are going to measure the internal resistance of this one. So, but I'm going to use the other one. You already learned in the previous labs how to use both of them. And this power supply, as you see, it has four channels. Okay, this time you are gonna learn how to use it as a current source. Okay, so unfortunately, as I told you guys, I give some picture to students to just help them, but unfortunately, some students just copied they copied the circuit here, and they did not even learn how to connect a meter, or how to use a meter or voltmeter, or how to use the power supply. This is going to be a problem in coming labs. So you need to learn in this lab, because now I am assuming you already know how to use this, because that's what we have done. That's what we have done. You already know how to use this ammeter and this meter and this meter. Now, after you finish this lab, you should be able to connect either voltage source or a current source. Okay, so in the coming lab they will come. So if you in the coming labs, so if you don't learn it here, it's gonna be a problem for you in the coming labs. Okay. Anyway, so here in this part here, as I told you, you need to measure the values of V1, V2, I1, I2, I3, and then you need to compare between the simulated and the computational results. Okay. One more thing here, asking you to calculate the total resistance. Sorry, not calculate, to measure the total resistance. So what you have to do here, guys, when you go to this circuit, for sure, for the total resistance here, for sure you can calculate it, right? You can see R2 parallel to R3 series with R1. I just want to make sure, okay, if you do the calculation for the total resistance, it will be the same value, or it's going to be very close to the measured value. Be careful here. When you measure the total resistance, you have to remove Vs. Be careful here, guys. Okay, so when you measure the total resistance, you have to remove Vs completely, and you have to put the ohmmeter, one terminal here and one terminal here. Make sure you have to remove Vs. Otherwise, you may make damage to the ohmmeter. Say it again. I want to measure the total resistance for this circuit. So I'm going to connect it this way, but I'm not going to connect the voltmeter. All what I'm going to do, I'm going to remove this part, and then I'm going to connect here. One terminal here of the ohmmeter, the other terminal is here. Remember, the ohmmeter internally has its own battery, and the ohmmeter is gonna supply current here, okay? And then the ammeter, what the ohmmeter is gonna do is gonna use Ohm's law, so it's gonna see what voltage we have here and what is the current to calculate the total resistance. You see what I'm saying? That is why you should be, there is no other source, okay? Because ohmmeter itself internally, it has a source, okay? And this source is going to provide current to the circuit, and then it will use Ohm's law to calculate the total resistance. Again, make sure when you use ohmmeter, there is no power supply here, okay? I think that's all what I have. Good luck, okay?